Hi friends, let us start the second part of Module 5. The topic is rotation under a constant moment. This is also a simple topic. This is just similar to what we have seen in motion of connected bodies, which we have discussed in part 5 and part 6 of Module 4. The link of those videos will be given in the description box. If you haven't gone through those portions, please go through, understand the concepts, and after that only go through this video. So let us start. Here the moment or torque will be a constant. We know the torque or moment is represented by the letter T. So that will be a constant value. Let us see a problem directly so that it will be more clear to you. The first problem is a pulley of 600 Newton has a radius of 60 centimeter. A weight of 400 Newton is suspended by a string wound around the pulley. The other end of the string is attached to the pulley as shown in figure. Determine the acceleration of the weight and the tension in the string. So the figure is given in the question itself. There is a weight of 400 Newton. It is connected by a string to a pulley of 600 Newton weight. So this is just similar to what we have seen in the motion of connected bodies. It may be related to that of motion of lift. So in that case, what was the equation applied? Just there was a single equation, which is Newton's second law. Net force in the direction of motion equal to mass into acceleration. So we'll be applying the same equation over here also, but there is one difference. In that case, the weight of this pulley was not specified. If you have any doubt, please go through it. You can see that the weight of pulley, they haven't said anything about the weight of pulley. Here in these problems, they will be saying about this pulley weight also. So that also is to be considered in this module. Now let us see how to do this problem. So one part you have already studied, net force equal to mass into acceleration. Before that, as this weight of pulley is given, we have to consider that. So in order to do that, we will be considering the torque. So torque means we know there are two equations for torque. We have studied it in the last part. Torque is given by I into alpha, where I is the mass moment of inertia and alpha is the angular acceleration. Similarly, there is one more equation for torque, which is force into distance. So let us see, this is the original figure. So if you are representing the figure like this, 400 Newton weight, this is the pulley, radius is represented by R. Now we want to calculate the tension and acceleration. So let P be the tension in the string. Normally we will be representing by the letter T, but here we have already specified T as torque. So no need to confuse between this torque and tension. So let torque be represented by T itself. Let we represent the tension in the string by the letter P. So let P be the tension in the string. Now torque, it is force into distance. Here what will be the force? It is tension into distance about the center. So it is torque is this tension P into radius R. So that is one equation for torque, which is P into R. The other equation is, which we have already studied, which is I into alpha. Now how to calculate I? There were two methods to calculate I. Either they will be giving the radius of gyration or they will be specifying the section. Here radius of gyration they haven't given. Instead they have given it is a pulley. We know pulley is circular section. If it is circular section, what will be moment of inertia? Mass moment of inertia, it will be mr squared by 2. In order to avoid again the confusion between small m and capital M, this capital M is for the pulley mass. So capital M is for pulley mass. That mass is already given. It is 600 Newton. 600 Newton means, is it weight or mass? Newton means it is weight. So you have to convert this weight into mass. Anyway, we have T is equal to, that is torque equal to P into R. T is equal to I into alpha. I is mr square by 2, which is pulley is circular. And this alpha is also converted in terms of linear acceleration. So what is the equation for that? A is equal to R alpha, where A is the linear acceleration, R is the radius, alpha is the angular acceleration. So substitute alpha equal to A by R in this equation, you will be getting MAR by 2. Now equating these two, we had two equations for torque. Equating these two, you will be getting P into R equal to MAR by 2 or P equal to MA by 2. So anyway, this will be the final equation in all these cases. Don't by heart this equation, just understand how it came. There were two equations. While solving these two equations, you will be getting the tension, which is ma by 2. That is mass of that pulley into acceleration by 2. Now what is the mass? It is weight is 600 Newton. So mass is 600 divided by 9.81 into acceleration into A. This 2 is already given over here. So it is 2. Let it be equation 1. Now we will be applying Newton's second law. Now where will be the motion of this body? This 400 Newton, it will be going downwards, isn't it? This 400 Newton weight is connected to pulley. So as there is a weight, it will be acting downwards. It is downward motion. As this is in downward motion, this angular acceleration is given, angular velocity or rotation is given in the clockwise manner. This is going downwards, so rotation is in the clockwise manner. Now we will be drawing the free body diagram. This is 400 Newton is acting downwards. P is the tension, it is acting upwards. Motion is downwards, acceleration is downwards. So all these things we have discussed in module 4. Now net force equal to mass into acceleration. What is the net force in the direction of motion? Motion is downwards, so net force is 400 minus P. Why it is 400 minus P? Because in the direction of motion, it is taken as positive. So in the direction it is 400 is positive, P is negative. So 400 minus P is equal to mass into acceleration. Mass of what? Mass of, it's not the mass of pulley, it is the mass of this body itself. So mass of this body is 400. Weight is given as 400. So mass is 400 divided by 9.81 into acceleration. So now it is 400 minus P. We already got a value for P, which is 600 divided by 9.81 into A by 2. So substitute this equation 1 in equation 2. Solving these two equations, you will be getting acceleration as well as the tension. So this is the method to calculate the acceleration as well as tension. So the same method is followed throughout. There is nothing special in this. Normally, as we had done in previous module, there will be Newton's second law, which is net force equal to mass into acceleration. Before that, calculate this external torque. There are two equations for torque. Equate those two equations and find a value for this tension. Substitute this tension in the Newton's second law. You will be getting what is required. Okay, second problem. A solid right circular drum of radius 0.3 meter and weight 150 Newton is free to rotate about its geometric axis as shown in figure. Wound around the circumference of the drum is a flexible cord carrying at its free end a weight 45 Newton. If the weight is released from rest, find the time t required for it to fall through the height 3 meter. So the figure is given. There is a right circular drum, solid circular drum. A weight is attached to it. Here in the figure it is given as Q. This Q is equal to 45 Newton. The weight of this circular drum is 150 Newton. It is similar to the previous problem itself. Here instead of acceleration they have asked us to find the time required when it is falling through a height of 3 meters. So as done in the previous problem, we will be doing the same method. Let P be the tension in the swing. Initially, we will be calculating the torque. So it is this tension P into radius. So it is P into R. Now, then also torque is given by I into alpha, where I is the mass moment of inertia. Here in the question, it is given as a right circular drum. So for right circular drum, moment of inertia is mr square by 2. This m is capital M, so it is m r square by 2. Then relation between a and alpha is a equal to r alpha or alpha equal to a by r. So alpha equal to a by r. Finally, you will be getting m a r by 2. Equating these two, that is p into r and m a r by 2, you will be getting p equal to m a by 2, where m is the mass of this circular drum. Here the weight is given as 150 Newton. So mass will be 150 divided by 9.81 into a by 2. That will be equation 1. Now we will be applying Newton's second law. So the weight is 45 Newton. The direction of motion, this will be acting downwards. So if you are representing it as free body diagram, 45 Newton acting downwards. P is the tension, it is acting upwards. Direction of motion is downwards. A is the acceleration, it is acting downwards. So by Newton's second law, net force equal to mass into acceleration. Net force in the direction of motion is 45 minus P equal to mass, that is 45 divided by 9.81 into A. So this is equation 2. Substitute equation 1 in equation 2, you will be getting the acceleration. Now what is asked in the question? If the weight is released from rest, which means initial velocity is 0, find the time t required for it to fall through the height 3 meter. So initial velocity is 0, the distance is given as 3 meter, acceleration we got it as 3.68. We want to find the time. So relation connecting all this is S is equal to ut plus half at square. So substituting, you will be getting t equal to 1.28 seconds. Next problem. The rotor and the shaft weighs 2500 Newton and the radius of gyration with respect to the axis of rotation is 250 millimeter. Calculate the acceleration of the falling with 450 Newton if the shaft radius is 125 millimeter. So the figure is given in the question itself. Here there are two circles. The inner circle represents the shaft that we know. Now connected to this shaft there is a weight W. This weight is 450 Newton and the total weight of this rotor and shaft is 2500 Newton. So this is the original figure given in the question. Now if you are representing it separately, this is the figure. Along with that there will be a tension in the string. Let P be the tension in the string. Weight is acting downwards, which is represented by W. So if you are representing the free body diagram, it is W equal to 450 Newton. P is the tension. Now what will be the direction of motion? Weight will be acting downwards itself, which means motion is downwards. Let A be the acceleration. So there is, even though there are two circles, there is nothing to worry in it. Just know in which circle the tension is represented. So here torque equal to force into distance. So force into distance means tension into distance. What is the distance? It is this radius itself. Shaft radius is 125. So as the inner circle is shaft, its radius is 125 millimeter. So torque is this P, tension P into R. We also have torque equal to I into alpha. So here they have given the radius of gyration. So what is the equation between moment of inertia and radius of gyration? It is k equal to root I by m, or I equal to mk square. So I equal to mk square, alpha equal to a by r. So we have p into r equal to mk square into a by r. Solving, you will be getting p equal to mk square into a divided by r square. What is m? It is the mass of this total rotor and shaft, which is 2500 Newton weight. So mass will be 2500 divided by 9.81 into A's radius of gyration, which is 250 millimeter, convert into meter, which is 0.25. Radius is 125 millimeter. So again it is 0.125 meter into acceleration A, which is unknown. So this is equal to P, which is equal to 1019.37 A. That is equation 1. Now we will be applying Newton's second law. So by Newton's second law, net force equal to mass into acceleration. So this is a free body diagram. Weight is acting downwards, P is acting upwards. This is the direction of motion, which is downwards. Then acceleration A is also downwards. So what is the net force in the direction of motion? It is W minus P equal to mass. Mass means it is 450 divided by 9.81 into A. So weight is 450 minus P. P from equation 1 you will be getting P. So substitute equation 1 over here. Finally you will be getting the acceleration. So it has been asked to find the acceleration of the falling weight, which is 0.42 meter per second square. Next problem. Two blocks of masses 10 kg and 25 kg are attached to the two ends of a flexible rope. The rope passes over a pulley of diameter 500 mm. The mass of the pulley is 7.5 kg and its radius of gyration is 200 mm. Find the acceleration of the masses and the tension on either side of the rope. So the figure is not given in the question. We will be drawing the figure. What is given? There are two blocks of masses 10 kg and 25 kg. It passes over a flexible rope. It passes over a pulley. So there are two blocks, which is 10 kg and 25 kg. It is connected by a flexible rope, passes over a pulley. So the figure will be like this. This is the pulley. Two masses 10 kg and 25 kg. Let block A is of 10 kg mass and block B is of 25 kg mass. Now as there are two strings, let PA be the tension in block 1 and PB with the tension in the string in block B. So we know, so P and PB is given. We want to find that. Now what will be the direction of motion? As 25 kilogram mass is greater than 10 kilogram mass, this block B will be moving downwards and block A will be moving upwards. So the first case, to find the torque equal to, we have two equations. First one, torque equal to I into alpha, that is mass moment of inertia into alpha. What is given in the question? To find I, the radius of gyration is given. The radius of gyration is 200 millimeter. So equation between radius of gyration and I is k equal to root I by m, or I is equal to mk square. So t is equal to I alpha, which is mk square into, instead of alpha it is a by r. Now we have one more equation for torque, which is what is it? Force into distance. Here, as there are two strings, it will be again the force into distance, the force of this string into distance also. Now take in the downward direction as positive, force as positive, and in the upward direction as negative. So it is, as this is moving downwards, it is PB into distance. Force PB into distance, that is up to distance up to center, which is radius. So PB into R minus PA into R. As PA is moving upwards, let it be negative. So minus PA into R. So it is PB into R minus PA into R. Now equating these two torques, you will be getting like this: PB into R minus PA into R equal to MK square into A by R. Simplifying, you will be getting PB minus PA equal to MK square into A by R square, where M is the mass of this pulley, which is 7.5 kilogram, into K is the radius of gyration, which is 200 millimeter. So yeah, it is 0.2 meter. Then A is the acceleration unknown. Radius is given as, diameter is given as 500 millimeter. So radius equal to 500 by 2, or it is 0.25 meter. So substituting all these things, you will be getting PB minus PA equal to 4.8 into A. Let it be equation 1. Now we will be applying Newton's second law. So let us see one by one. So first case, for block B, if you are writing the free body diagram, it will be like this: 25 kilogram acting downwards, PB, it is the force, it is acting upwards. Direction of motion is downwards. Acceleration is downwards. Here the acceleration will be same because it is the same flexible rope acting passing over the pulley. So if the acceleration over here is same, here also the acceleration will be itself. So for block B, it is net force. What is net force? It is, this is mass, so we have to convert it into weight. All these things we have seen in our part 5 and part 6 of module 4. So no need to have a detailed explanation. So it is net force is this force, which is 25 into 9.81 minus PB equal to mass. Mass is 25 into A. So PB will be getting this equation. Similarly for block B, it is motion is upwards. So it is PA minus 10 into 9.81 equal to mass. Mass is 10 into A. So this is equation 3. We have three equations. Substitute equation 2 and equation 3 in equation 1, and you will be getting the acceleration, which is 3.7 meter per second square. Now we have been asked to find the tension also. So for finding the tension in block B, substitute A in equation 2, you will be getting tension in block B equal to 152.75. Similarly, tension in the string in block A is equal to 135.1 Newton. Now let us see one more problem. The composite pulley shown in figure weighs 800 Newton and has a radius of gyration of 0.6 meter. The 200 kilogram and 400 kilogram blocks are attached to the pulley by strings as shown. Determine the tension in the string and angular acceleration of the pulley. So the figure is given in the question itself. It's a composite pulley, which means there are two circles. Inner circle is 0.5 meter radius, outer circle is 0.75 meter radius. The inner circle is connected to a string. At the end, there is a mass of 400 kilogram, and to this outer circle there is a mass of 200 kilogram. So this is the figure. Now let us see how to do it. Now as there are two circles in it, will the acceleration be same? We are not sure about it. So let us see. So this 400 kilogram mass is connected to the inner circle, 200 kilogram mass is connected to the outer circle. Let A1 be the acceleration of 400 kilogram mass which is going downwards, and A2 be the acceleration of 200 kilogram mass which is going upwards. Now, what will be the rotation? This is going downwards as 400 kilogram is greater than 200 kilogram. This will be moving downwards and this 200 kilogram will be moving upwards. So what will be the rotation? This will be rotating in a clockwise manner. As there is only a single rotation, there will be only a single angular acceleration which is alpha. No need of alpha 1 and alpha 2, as the rotation is a single is in a single way. It is a single angular acceleration which is alpha itself. So we have normally connection between A and alpha is A is equal to R alpha, but as there are two accelerations A1 and A2 and two radius R1 and R2, we can write it as A1 equal to R1 into alpha, where R1 is 0.5, so A1 equal to 0.5 into alpha and A2 equal to R2 into alpha. Here R2 is 0.75, so A2 equal to 0.75 into alpha. Now A2 divided by A1, you will be getting like this, and finally A2 will be 1.5 times A1. So that will be equation 1. Now let us do the things like what we had done in the previous cases. So first one, how to find the torque. There are two methods to find the torque. First one is force into distance. Since there are two strings, force of first case into distance. So it is T1 into distance 0.5. As this is downwards, we have taken downward as positive. So it is plus T1 into 0.5. And this is T2 is going upwards, so it is minus T2 into distance is 0.75, so it is T1 into 0.5 minus T2 into 0.75. Now we have one more equation for torque, which is I into alpha. As radius of gyration is given, we can write it as K equal to root I by M, or I equal to mk square. So torque equal to mk square into alpha. Instead of alpha, you can write it as either A1 by R1 or A2 by R2. Here we have written it as A1 by R1. So it is mk square into A1 by R1. Now equating these two, you will be getting 0.5 T1 minus 0.75 T2 equal to mk square into A1 by R1. Substitute those things which are known to you. What is M? It is the mass of pulley, which is weight is given as 800 Newton. So mass will be 800 divided by 9.81. What is K? It is 0.6 meters. So it is 0.6 square into A1 divided by R1. R1 is 0.5. So substituting, you will be getting this equation, which is equation 2. Now apply Newton's second law for each case. So let us see the first case of 400 kilogram block. If you are drawing the free body diagram, it will be like this: 400 kilogram mass acting downwards, tension T1 is acting upwards. This is in the downward motion, so motion is downwards. A1 is the acceleration, so A1 is also downwards. So net force in the direction of motion is 400 into 9.81. We have converted it in terms of weight, so it is 400 into 9.81 minus T, that is the net force, equal to mass, which is 400 into acceleration, is A1. So let it be equation 3. Similarly, consider the upward motion of 200 kilogram block. 200 is acting downwards. In terms of weight, it is 200 into 9.81. T2 is the tension. A2 is the acceleration. The motion is upwards. So net force in the direction of motion is T2 minus 200 into 9.81, which is equal to mass, which is 200 into A2. That is equation 4. Now substitute equation 3 and equation 4 in equation 2. You will be getting the value of acceleration, which is A1, which is 1.01 meter per second square, and A2 equal to 1.52 meter per second square. This thing you will be getting from equation 1. Similarly, to find the tension, substitute A1 and A2 in the equations above. You will be getting T1 equal to 3520 Newton and T2 is equal to 2266 Newton. And it has been also asked to find the angular acceleration. So angular acceleration alpha equal to either A1 by R1 or A2 by R2. From where you will be getting 2.02 radians per second square. So that's all about rotation under a constant moment. It is just similar to what we have seen in motion of connected bodies. Along with the motion of connected bodies, here in this module, there are two more equations to find the torque. So torque is equal to I into alpha, and torque is equal to force into distance. Force means tension into distance means radius. So solving those two things, you will be getting the tension in the string and substitute that tension in the Newton's second law. So this is the method to find the rotation under constant moment. I hope it is clear to you. If you have any doubt, don't hesitate to ask the questions. Feel free to ask the questions through the comment box. Thank you.